Okay, your output are your y values, your input are your x values. Okay. Yes, Ian. Yeah. In other words, you cannot have multiple x's in your domain. Okay. If I look at the ordered pairs here, 2, 1, 3, -2, -3, 1, and 2, -2. What can you say? What can you say about this? Is this a function? Does every x have exactly one y value? Okay. Again, watch this. X values must be different. Are all of my x values different? No. Here's a 2, and there's a 2. Go ahead. We'll wait. It's got to take a while, Ian. Just leave it in there and let it sharpen. Got it? All right, so this x has a value of 1 for its y. This x has a value of -2, so 2 for x does not have exactly one output. This is not a function, by the way. There's a lot of different ways we can represent something. This doesn't happen to be a function, but we can represent this, I'm assuming it's a line, this line as ordered pairs like it is here. We can represent it on a graph. We can represent it on these two ovals. This is called mapping. Or, what's this called? T-chart. Okay, a chart. By the way, with even all the math that I went through, and I've gone through a tremendous amount of math, I've always come back to using a T-chart when I'm stuck. You can use this T-chart over and over and over again. Okay, I was even using it in third year calculus. Okay, it's really a handy tool. All right, so let's graph these points. And the graph, I have 2, 1. So 2, 1, there's that point. Then I have the point 3, -2. So 3, -2 is another point. And then I have the point -3, 1. So -3, 1. There's another point. And then I have the point 2, -2. 2, -2. Now, don't draw a line because it doesn't say a line. These are just points. You're just charting points. Does anybody remember an easy way when you have a graph, whether something is a function or not? There's a real easy way when you have a graph. Yeah, that vertical line test, right? And believe it or not, we just taught our algebra, well, we didn't teach, but we reviewed this with our Algebra 2 students because they use it in Algebra 2. If I take a vertical line, and this is my function, it happens to be 4 points, supposedly a function. And if I take a vertical line and I move it across left to right, if this vertical line crosses at more than 1 point, it is not a function. So when my vertical line reaches this x equals 2, see how it intersects 2 points? It fails what's called the vertical line test. So this is not a function. So I'm telling you, the easiest way, especially when you have a graph, is use the vertical line test. if there was a 1.9, that is not the same as 2. Okay, so it would pass the vertical line test. All right, in fact, the next section you're going to use vertical line test. My domain are my x values. So my x values again are 2. And you don't have to put the curly brackets on there. That just means the set. The set of numbers 2, 3, -3, and 2, which I already have, so I don't need it. And if you want to make your Algebra 1 teachers really happy, you could put this from lowest to highest. -3, 2, 3, with your curly brackets. Boy, that would really make your algebra teacher really happy. We already said this is not a function. Huh? So that's graphing it. That's graphing it. This is called mapping. Oh, wait, what's my range? My y values. My y values are 1, -2, 1, we already have 1, and -2, so I already have -2. My y values. Okay, if we wanted to use the mapping method, my x values again, I have 2, 3, and -3, should have put them in order. And then I have 1 and -2. Okay, and it's called mapping because you look at each point, 2 maps to 1. 3, Carson? 3 maps to -2, to 1, and 2 maps to -2. Okay, it's called mapping. And then our t-chart is just our mapping in our or just the points. I have 2, 1, 3, -2, -3, 1, and 2, -2. Okay, that's my t-chart. So, 4 different ways to represent this particular problem. You know, you guys are like on the track of it absolutely having no electronics other than the Chromebook next semester. Don't put it past me to do it this semester. It's just so disrespectful to me. I don't ask a whole lot from you guys. 15, 20 minutes, even if that, to not listen to music and focus on what I'm saying. I don't ask a whole lot from you guys. Okay, let's look at problems 1 through 4. Let's use our vertical line test to see if these are functions. Okay, I'm going to take my vertical line, I'm going to go left to right. Does it cross the graph at more than one point? No. So it is indeed a function. Correct. Number 2 is not a function because it starts intersecting points from here on out. See how it intersects at 2 points? Yeah, it could be a curved line too. It doesn't have to be straight. Okay, number 3, I have a graph of a set of points. Just make sure they're not on the same vertical line. And they are not, so this set of points is a function. And then number 4, do I have any points on the same vertical line? And right there I do. So this is not a function. Okay. Now, number 5 and 6, look for the same x values. In fact, if it helps, circle your x values. I got a -2, a 1, a 2, and a 0. Is that a function?
Yes.
Yeah. No. But I'll tell you what, it's really easy to make a mistake on these. What about number 6? I have
Not a function because it has 2 positives.
Yeah, because I have 2 positive 5s.
No.
Good. How about the first t-chart or table? Is that a function? Nope, because I have 2 3s. 2 3s with different y values. Be careful, they might trick you up. How about number 8? Yes, it is. Okay, page 2. Here's some mapping diagrams. Number 9. Here's my x values, the domain. Here's my y values, the range. Is this a function? Yes. Correct. How about number 10? This actually means that this 2 is being mapped to 2 different y's. Okay, so this is not a function. Okay, be careful. All right, this next part is probably the hardest part of this whole section. The f of x, see this notation here? That's called function notation. All we're doing here is we're replacing y with the f of x. That's all we're doing. Yeah, so in this particular f of x, the equation is the f of x equals 3x minus 8. The reason why we like function notation is because it actually saves us some time as far as substituting in values. Okay. Now, in number 11, said, well, instead of putting the f of x, we're going to put in the f of -2. In which case, that equals our x. -2 equals our x. So wherever I see an x, I'm going to substitute in -2. So I have 3, and here's my x. Okay, I'm going to plug in -2
So would that first f
minus 8.
So would the 2 also be informed by the f not be used in the equation?
Well, now it's acting as a symbolization. Okay.
So it's just being
This is acting as a symbolization for x, as a value for x.
So you wind up with -6.
Correct. So this equals -6 minus 8.
The answer is -14.
So the f of -2 equals -14. Okay. Now number 12, it says, well, I have the g of n. In this case, my x, again, remember, whatever's in the parentheses equals x. I have to use the g function, so it's this function. So the g of n, now wherever I see an x, I put in n. So I have n squared plus 6. And I can't simplify that anymore. It's my answer. You with me? Okay. I don't know if you're joking or not, do I? I never can tell. I don't know if you're joking or not. Now my m plus 2 equals my x. It's the f function, so I have to use 3x minus 8. So the f of m plus 2 equals 3. Now wherever I see the x, I have to plug in my m plus 2 minus 8. That's my answer. Hmm? I didn't hear you. Seemed to be pretty good. Okay, 15. I have the g of m. Shh. Remember, the m equals the x. And then after I put in the m for x, I'm going to add 2 to the whole thing. So let's put in m for x. So I have m squared plus 6. Then I'm going to add 2 to the whole thing. Yep. So g of m plus 2 is going to equal m squared plus 8. Okay? Now when you get into Algebra 2, these composite functions can get horrendous.
Can they?
Yes. Very extremely complicated. Calculus is even worse. No.
I'm going to get into the calculus class. I'm just going to go. Oh, good. I'll be good.
I'm not going to worry about number 19.
Yay.
18 we could do.
No.
The g. Now remember, this equals x. So the g of n minus 1 equals x squared. So this is my x. So n minus 1 squared plus 6. And we're going to leave it there for Algebra 1. Okay. That's as far as you have to go with that. So in your books, and for your book work, oh wait, you don't have a book, do you? Oh geez, so I guess I'll just print them out for you. No, this is ours. Yeah. Okay. Yep.